Hi, this is a video walkthrough of our security lab. Here I'm going to demonstrate that the security lab have been completed successfully, and I'm going to walk you through what have been done for the lab. So on the first part here, we will be talking about the OS installation and the hardening. The objective is to demonstrate that the Ubuntu 24.04 LTS is fully patched with App Armor in enforced mode. The SSH is configured for key-only authentication with root logging disabled, and automatic security updates are enabled and unnecessary services has been removed. So first of all, with this command, I'm going to show that Ubuntu has been installed and with the correct version. And here you can see that the App Armor module is loaded. Mm, And with this command, you can see that you have no root logging and no password authentication. Mm. And with this one, you can see that the automatic security update is enabled or are enabled. And here you can see that only the necessary services are running. So that's all for part one. We're moving soon to part two. Here, this is part two, which is related to Apache Web Server and hardening. In this part, we'll be demonstrating that Apache has been hardened by hiding version information, disabling listing, and enabling mode security WAF with OWASP rules to actively block attacks. Security headers protect against clickjacking, XSS, and MIME sniffing, and also SSL is enabled. So with this first command here, we'll be showing that Apache is installed and is running. With this one, we can see the version of Apache that has been installed. And next, with this, you can see that the security modules have been loaded. We have the mode security, the model security, the SSL, and the headers. And this one demonstrates that the module security WAF is active. Mm. So here we can see that the server version info are hidden. And here we can see that the directory listing is disabled. And finally, with this, we can see that the security headers have been configured. That will be all for part two. Moving on to part three, this we have to do with the SSL, TLS, and HTTPS redirects. In this walkthrough, we will demonstrate that all HTTP request traffic is automatically redirected to HTTPS, and a self-signed certificate is used for the lab environment. So right now we are on HTTP with type HTTP and the public IP. When I press enter, I have a warning message that in which I will have just to click continue to site, and you can see that the traffic has been routed to HTTPS. And with this, we can have access to our blog page. That will be all for part 3. Yeah, welcome to part 4, in which we demonstrate that MySQL has been secured with a root password set and anonymous users removed. And the test database dropped, and a dedicated WP user with least privileged access is used for this. So with this first command, we can see that MySQL is running. And with this next command, we can see that that the test database has been dropped. Mhm. And the WordPress database exists as well. With the following command, we can show that there is no anonymous users. Just a second. There we go. Here we have all the users that are in the database. And with the following command, we can see the version of PHP that has been installed. And with this last one, we can see also the modules that came along. That's all for part 4. Thank you for watching. Welcome to part 5. Here we will demonstrate that the NF tables enforces a default deny policy allowing only SSH, HTTP, and HTTPS traffic. All the traffic is dropped and logged. The log entries show a real block connection attempted from the internet. So with this first command, we can see the service that is active, the NF table service active. With this following command, we can see the policy, the default drop policy. With the next command, we'll be able to see that only the port 20, 80, and 443 have been enabled or allowed. And with this next command, we can see the default policies. And finally, here we will be able to see a proof that a proof of the dropped package in our logs. That will be all for part 5. Right, welcome back to part 6. Here we will demonstrate that fail2 band monitors SSH and Apache logs for suspicious activities. We have a free failed SSH attempt result in a 1-hour IP band enforced via NF tables. The fringes are active, that are active are SSHD, Apache Auth, and Apache Backbots. The tool uses NF tables for enforcing rather than IP tables. So we now show that with a couple of commands. So with this one, we can see that the fail2 band is running. Here we can see the active jails. We have 3 active jails: Apache Auth, Apache Backbots, and SSHD. So with this, we can see the SSH jail details. With this command, we can see the Apache jail details. And here we can see the configuration that shows NF tables backend and bend time. So with this, we can see the duration, the band duration, which is about an hour, 3,600 seconds. And with this command, we can see the max number of retries, which is 3. That's all for part 6. So this is part 7, which will show that OSSEC services as the host-based intrusion detection system complied from source. It monitors file integrity on Apache configuration and WordPress files. It runs rootkit detection, analyzes logs, and can auto-ban IPs via active response. It runs as a systemd service on the both. So I'm going to be running a couple of commands to demonstrate. Mhm. With this one, we can see that the OSSEC components are running. With this one, we can see the file integrity monitoring configuration. It shows the monitored directories. With this, we can see the Apache and WordPress directories monitored. With this one, we can see the rootkit detection enabled. With this one, we can see the recent alerts that has been kept in the logs. And in this one, we can see the configuration that shows that it starts on boots via systemd. That will be all for part 7. Now, welcome to part 8. In this part, we will be showing that the WordPress has been hardened with a file editing disabled from the dashboard. The SSL enforced for admin access and auto update enabled. The WP config.php file is locked to chmod 400, and XML RPC is blocked to prevent brute force and DDoS amplification attacks. 3 security plugins are installed, both fans for WEF and malware scanning. WP2FA for two-factor authentication, and limits logging attempts reloaded for application level brute force protection. So this part we will be going first through the terminal to show a couple of we run a couple of commands. First of all, we run this command to show the WP config.php hardening detection directives. So with the following command, we will show the WP config PHP locked down with read only access for 2W data. With this next command, we will show that the XML RPC is blocked and no directly and there's no directory browsing. So with this command, we can see the file permissions and the owners. And from this, we'll be going to the browser for a short demo. So here we are in our web page, WordPress web page. We can have a look into the plugins. You can see also the one that we have referenced limits logging attempts reloaded, word fan security, and WP2FA two-factor authentication for WordPress. We can also see the users, that there is no default admin user, only the Sec935 admin that we have created. And in settings here, we can see the HTTPS URL. Mhm. So you can also see in this link um, that we have a limited access. I can maybe reload this page and you see that we get an error 405 dot method not allowed. And that will be all for our part 8. So to conclude, just a brief summary. For the network layer, we have had NF tables firewalls, plus you can see also AWS security groups. For the authentication layer, we have failed to band plus SSH key only plus limits logging attempts, limited logging attempts. And for the application layer, we have the mod security WAF, the word fence plus W2FA. For the system layer, we had AppArmor and OSEC, which include file integrity, rootkit detection, active response. And finally, for the configuration hardening, we had Apache version hidden, directory listing off, and XML RPC blocked, as well as WP config locked. So in conclusion, every layer of the Slack is protected from the network with NF tables to authentication with a failed to band and to FA, to the application with two WAFs, to the system with OSEC monitoring everything. This demonstrated a defense in-depth approach to the security and production web serving. Thank you very much.